Okay, everyone. So, chicken will start. Now, let's talk about the next case that we are going to discuss. Is basically the case at which the object is at 2f. So this case will be repeated for the concave mirror. That means if the concave mirror in the concave mirror, the object was about at C. But right now we are talking about the object is at 2f1, that inside the lens. Okay, basically for the lens if we're talking about. Now let's talk it about. So it would be basically when the object is placed at 2f1, right? So it would be like this.
बच्चे मिल जा बाहर इनसे जो है सलाम हो जा हमें मिल जाता है ये भी सलाम मुस्तकिल करते हैं बच्चे भी करती हैं वो तो
So okay, so first ray would be parallel to principal axis, isn't it? Okay. So first ray would be parallel to the principal axis and the second ray would be passing, the same ray would be passing through the focus. Okay.
हमारी जान पहचान इस मुद्दे से कैसे होगी बस ऐसे कहीं मिली नहीं नहीं यहीं बस यहीं पर देखना है तो आज तो बच्ची दिख गई
Okay. So second ray will be passing through the optical center.
ना जब बच्चे ना थे तब मैं चली जाती थी गार्डन पे जाकर तो मुझे नहीं हो जाऊँ आजकल मैंने उसकी बच्ची ना देखी कैसी अच्छा तो ना पता क्या
ठीक है See this thing. So object is at where? At the point of intersection, that is your at 2f1 2f2 sorry. Okay. So what would happen basically was left has left. So the object
पूरे सर्दी में ही रही लड़की नहीं हाँ वही तो मुझे भी पता ही है बस तो वही है बगैर मैंने देखी नहीं
See this thing, the object is the image is forming at 2f2. Okay, that means of the same size. Yes or no, everyone? Just like the size of the object. Got it?
Yes.
Okay, and if we talk about the case of the properties of it, so it would be when the object is at 2f1, the image would be formed at 2f2. And the nature of the image would be really inverted and same size. So please note it down and let me know once done.
So I think we still did not write the second one.
Could you please
C.
repeat?
Sir, I think we did not draw the second one beyond C.
So we have not completed the second one. That's what you're saying, Inan?
Yes, sir.
Okay, no worries, Inan. Let's do that. If you are saying that, maybe. So let's do it. Go ahead. Same thing would happen basically. The light ray will be passing through, but the image would be forming. Let me just show it to you how to draw it. The object would be beyond 2f1. Chicken. So first light ray would be parallel. Second light ray will be passing through the focus.
Sir, I can't hear you.
Hello, am I audible, Ifra? Hello, am I audible?
Yeah, ma'am. You weren't audible.
अच्छा, actually maybe कुछ आपके network issue था जब आपने class left की. That's a network issue. Okay, so of this, the second ray will be passing through the optical center and it will basically go straight as it is. Okay. Just a second. So as you can see here, the image is formed smaller than the object, so it would be a diminished image and be between f2 and 2f2. Please let me know once done. Please note it and let me know once done. Okay, Nan, clear?
चलो फिर आप बैठो फिर आओगे बैठ नहीं चाय ना बस ना ना ठंडा परम दिया जब चला था साथ गया था देखो देखो हाँ सेम चलो ठीक है बाजू फिर आऊंगी ठीक ठीक है साल की हाँ
So, Rumesa is trying to join, but the link is not working for her.
अच्छा ठीक है so she can just like please just let me just check with the management.
Okay.
I will inform the team. Okay.
Okay.
And all of you.
Yes.
Okay. Inan done. Are you there?
Yes, sir.
Okay, done. So first
Yes, sir.
first three cases are there. Okay. Next case is basically now the image is formed beyond to f. Basically, image is between. So the object is between to f1 and f1. Okay. Now let's place the object over here. Here is the object. Is it? So first ray would be parallel to the principal axis. Okay. So the second ray. Okay, well, this is. Okay, see this image that the image is forming beyond to f1 because the object is between f1 and 2f1. Okay, and it's basically 2f2. The image formed would be enlarged and the real and inverted. What happened, Ifra? क्या हुआ? You're thinking something?
No, sir, I just seeing the diagram.
अच्छा ठीक है. So done with the drawing part?
Yeah.
चलो ठीक. Is this clear? Like everything is clear so far to all of you? Afrin, Ifran, Inan?
Yes.
Yes, sir.
Sir, 1 second.
Ha, yeah. No. Okay, Inan. Okay, take your time. I did like there was no class today, but I thought like I have a slot free, so I can just schedule some classes for you because your exams are coming in the 15 days. So I thought we should cover it up as soon as possible so that we can start the revision as well. Second chapter is coming complete.
Yeah,
Like
yeah,
it's,
the whole one eye and the colorful world, but there are no numericals in it.
हाँ न्यूमेरिकल्स तो नहीं है उसमें, बस एक दो न्यूमेरिकल आते हैं. या तो आपको वो पावर ऑफ एलेंस कैलकुलेट करने के लिए कहता है, आपकी जो माइपिक आई होती है हाइपरमेट्रोपिक आई होती है उसके लिए, उसके अलावा कोई न्यूमेरिकल नहीं है. सो कंप्लीट चैप्टर आ रहा है वो.
Yes.
Yes.
हाँ दैट्स व्हाई. अच्छा वो आज क्लास लग गई कम से कम मुझे पता तो चल गया. ठीक
But
है कोई
we
नहीं बट
completed. Actually, मैं हम लोग का हाफ ईयरली का क्वेश्चंस आज ही भेजा है. They told us पहले से, but आज क्वेश्चंस भेजा.
कंफर्मेशन आज हुआ है, मतलब कि
हाँ.
हाँ ये ऑफिशियल कंफर्मेशन है. चलो
Yes,
ठीक
yes.
है. नहीं बेसिकली क्या होता है ना, पीछे भी काफी स्कूल्स ने ऐसा किया, बताया 2 चैप्टर थे और दिए एक चैप्टर है 1.5. सो दैट्स व्हाई आई वाज थिंकिंग कि समहाउ अगर 1.5 चैप्टर दिया, सो इसलिए आई वाज जस्ट आस्किंग. चलो ठीक है कोई नहीं, 2 चैप्टर्स हैं कोई बात नहीं, इसको इंशाल्लाह विल डू इट लाइक 1 2 विद इन 2 क्लासेस विल कंप्लीट इट. एंड आफ्टर दैट जो भी टाइम लगेगा लाइट चैप्टर में तो ह्यूमन आई में तो देखो ज्यादा टाइम नहीं लगेगा. ह्यूमन आई विल टेक ओनली 3 to 4 क्लासेस.
It's all basic theory.
हाँ थ्योरी टॉपिक है, उसको ऐसे ही कवर अप करेंगे, मैं आपको एक्सप्लेन करूंगा. बस आप नोट्स जल्दी जल्दी प्रिपेयर कर लेना, उसमें ज्यादा कुछ नहीं है समझने के लिए, बहुत इजी है. मतलब लाइट का जो डिफिकल्टी लेवल दैट्स हाफ ऑफ इट ह्यूमन आई का.
Yeah.
ठीक है ना?
We studied that chapter in eighth. Yeah. Eighth
हाँ
में था.
ऑलमोस्ट
Light.
सेम. यस आई इज देयर. न्यू चीज दैट विल द न्यू थिंग दैट विल स्टडी इज एटमॉस्फेरिक रिफ्रैक्शन, स्कैटरिंग ऑफ लाइट. So these are the new 2 things and the defects. नथिंग मोर देन दैट। हाई चैप्टर में सिर्फ रे डायग्राम इंपॉर्टेंट है, एक प्रिज्म का और एक डिफेक्ट्स ऑफ विजन जो करेक्शन के होते हैं, ठीक है। ओके, नेक्स्ट केस ड्रॉ करो जल्दी से। ये सिंपल सा केस है, व्हेन द ऑब्जेक्ट इज एट इंफिनिटी, सॉरी इज एट द फोकस, द इमेज विल बी फॉर्मिंग एट इंफिनिटी, ठीक है ना। Then all of you. Okay. And this is the last case. That is one of the most important case of the spherical mirror, spherical lenses of the convex lens. Okay, let's draw it. Now the object, the last case, object will be between F1 and O. Okay, na?
Hi now. क्या तुम ले लो?
Just a second. Actually, I just washed my hand because that's why they're a little bit wet. So let me just spray them. Yeah. Okay. So okay, so the light ray would be going like that. So its first ray would be coming parallel to the, sorry, passing through the focus. Okay. बच्चों प्लीज प्रे फॉर मी एज वेल, मेरे भी एग्जाम है 29th को, ठीक है। सो प्रे करना अच्छा जाए। अभी मैं आपको पढ़ा तो रहा हूँ, मुझे भी पढ़ना है अभी। सो प्लीज प्रे फॉर मी एज वेल।
Good luck, sir.
थैंक यू। लाइक द वाइवा गॉट, लाइक वाइवा वेंट वेरी वेल। जो प्रोजेक्ट का वाइवा वगैरह था, दैट वाज वेरी सुपर। टीचर वाज इम्प्रेस्ड। अब बस ये एग्जाम और हो जाए, फिर टेंशन फ्री। माय ग्रेजुएशन वुड बी कंप्लीटेड। Okay, so here is it. Okay, why? Because actually they are not meeting because they are diverging. They are spreading out. Like, so if they are spreading out, that means they are not going to meet at any point if you even extend them. What would happen? You have to assume that they are originating from a common point. So that's why we extending them in the backward direction. What would happen? Basically, you can see the image is forming in front of the lens, or you can say on the same side of the object and of the big size, or you can say enlarged size. ठीक है ना? Is this clear? And this is the only case in which the virtual image would be formed. ठीक है? क्या हुआ रोमैस ने ज्वाइन नहीं किया अभी तक? आई थिंक मे बी नेटवर्क इशू. शी हैज सम नेटवर्क इशू.
Done, sir.
Okay, बच्चों. ठीक है. So please draw this table and write down the applications. This is very important. 2 marks question comes directly straightforward. Write the 2 applications of the convex lens. जैसे हमने एक मिरर में किया था, same thing would be happening for the lenses as well. ठीक है?
Sir, these applications, right?
Just applications, yeah.
Yeah.
Mature, please do let me know once.
Sit down.
Now let's talk about the concave lens, everyone. Okay, so in concave lens, the concave lens is a diverging lens. That means once the lens is basically light is spread, or basically the light strike the concave lens, the light diverges out. Okay, just like in the convex mirror. Okay, and the focus of the concave lens is negative. Okay, and concave lens always produces virtual, erect, and diminished images, just like the convex mirror. Only thing, yes or no? Clear? Please write down these things, and after that we'll discuss the ray diagrams. Done, mature. Everyone done? Ifra, Afrin, Inan.
Last one.
Acha, last.
Yes.
Check. Okay. Bit fast, everyone. I just wanted to wrap up this topic as early as possible, because we have to start the human eye. Like in the coming class, inshallah, we'll start the lens formula. And if we've got time, so we'll start the lens formula in this class itself. And if not, we'll definitely start in the next class. And after that, if we talk, okay, so within 1.5 classes, this chapter would be done. Because lens formula, then half topic is half class for the power of a lens. It's basic topic. Done. Can you move forward with the ray diagram?
Yes.
First ray diagram would be simple. plane. Light rays parallel, they will diverge, but they are not converging. So we have to extend them in the backward direction to the focus. So the image formed would be at the focus. It would be highly diminished. It would be virtual or indirect because the image, the light rays are assumed to be intersected. Okay. Clear? Okay. Please draw this one. Inan, is this clear? What happened to Afreen? She left the class.
So she probably had some network issue.
Acha, Inan, Ifra, clear?
Yes, yes, sir.
Check. Inan, are you there?
Yes, sir.
Check. Done. Can we move to the next one? Okay, now let's move to the next one. Okay. So, so the first, the object, okay, so here is the case that object is wherever, like you can place the object wherever you want between the infinity and the optical center. Okay, and the diagram would be same. I mean, the image formation would be same. Doesn't matter where you're placing it. First, I would be passing through the principal axis, parallel to the principal axis. Like, stick it. So I'll just draw it a little bit. And after that, just draw the ray diagram in the backward direction.
Sir, when we make this lens, right, through compass or something, it comes out really thick, right? It's supposed to come out really thick.
Uh, like concave one.
Yeah.
Like no need to no need to draw with the compass. At least just take a coin with you. Okay. And after that, just use it like that. Half draw this and half from the curve line and just use it with the scale. It would be enough like that. No need to draw with the
Very
compass.
unequal and very uneven.
Like try to be a little bit symmetrical if possible with the rough hand, because obviously you're not like it's not a symmetrical figure. You have to draw with the curve and then straight line. So try it, because if you draw the lens very big, so that would be a problem for you, because you have to draw a very big ray diagram and you have very sufficient pages in the you can say boards. That's why. ठीक है ना? That's what it is. And the second ray would be passing through the optical cell. And here so this is the image formation point, and hence the image would be formed here. See this thing? The image formed is virtual erect and diminished. Not highly diminished, it's diminished because it has some height. Okay, so this is the ray diagram. Please draw it, everyone. Done all of you?
Yes, sir.
ठीक है. Please note down the applications of the concave mirror lenses. And all of you? Just give me a second.
Yes, sir.
So last one.
Shake, yeah. Okay, Nabil. Okay, no worries.
Yes, sir, done.
Chicken. Just give me a second. Okay, so with this, the topic of the image formation is done. ठीक है? So next class में इंशाल्लाह हम लोग क्या करेंगे? लेंस फॉर्मूला स्टार्ट कर देंगे। लेंस मैं अभी लेंस फॉर्मूला का मैं बता देता हूँ, थोड़ा सा आइडिया दे देता हूँ। ठीक है? ठीक है, चलो लेंस फॉर्मूला का ये ठीक है, लेंस फॉर्मूला easy. It's just the repetition of the mirror formula. So basically, first of all, in the lens formula, you have the same type of formula. The difference would be a very small. That is basically instead of positive, here would be negative sign between the V and U, and here in the magnification portion, V and U are same, but instead of negative, it's completely positive. You have to use the sign convention. Here, as if everything is written, you have to use the sign convention of it. Okay. So, and the formula would be same for the H dash and H. Clear all of you?
Yeah.
ठीक है?
सर
हाँ, yes.
एक्चुअली मेरा अभी ये साइंस एग्जाम हुआ था, राइट? सो
हाँ,
जो मेरा फिजिक्स का क्वेश्चन था, वन ऑफ द क्वेश्चंस, उसमें आई गॉट द करेक्ट वैल्यू 36 and 3. ओके, द वैल्यू वाज 36 minus 36 and 3, बट आई रोट 36 and 3. बट जब व्हेन आई डिड द क्वेश्चन, राइट, तो उसमें पूरा माइनस कट रहा था बिकॉज देयर वर 3 माइनस एंड सब कट रहा था वो माइनस. तो आई डिडंट
So V
अंडरस्टैंड.
की वैल्यू आपको निकालनी थी आप.
यस,
हाँ, तो V की वैल्यू पॉजिटिव आती है ज्यादा अगर कॉन्वेक्स केस है, कॉन्वेक्स लेंस है आपका, तो
इट वाज कॉनकेव.
कॉन्केव फिर रॉन्ग है, क्योंकि V की वैल्यू नेगेटिव आती है कॉन्केव के लिए.
Sir,
बट
like
आई स्कोर्ड
both.
Yes, yes.
20 on my out of 20.
Okay,
Sir,
okay. Okay, no worries if I will discuss it in the next class. Like you can send me the question like through the official number, and after
Yeah.
that we'll discuss it in the class. No need to worry.
Okay, okay.
Yes, Inan, what you were saying, Bacham?
sir, the both convex lens and concave lens focal length is negative, right?
For both convex lens, nahi. Convex lens has a positive focal length, Inan. Because see this
Convex
thing, Bacham.
lens.
Convex lens. Okay, let me give you one thing. Let me give you one shortcut. Whenever you hear the word convex, the focal length of mirror and lens both would be positive. Okay? Whenever you hear the word concave, lens and mirror both, the focal length would be negative.
Sir, but both focal length lies on the left side of the plane, right? So why?
No, Inan. No, how? See this thing. We have just drawn the figure. Check it out, the figure, Inan. How is it possible? The image, where is the intersection point? Here. See this thing. This is the intersection point. Huh? You are going from optical center to F2. This is the point of intersection. And that's what your F is. Okay?
Okay, sir, understood.
But when the light ray is coming in from this direction, because that is not the part of his syllabus, the opposite direction. In that case, the focal length would be negative because lens has two focal length. One is negative, one is positive. Same with the concave lens as well, right? So, but right now in 10th standard, you are only studying the positive one. No need to worry about the negative case. In the convex, it would be positive always. Got it, Inan?
Yes, sir.
Chicken. Okay, everyone. So with this, let's end this class. And